Okay, are we ready to do this thing? We've got kind of a tropical pattern here in Texas. You can definitely see that by the convective debris that we've got flowing over us. The flow is now out of the west here. So that's a big change from the past couple days. Otherwise, looking pretty good out there, and we will switch over to the live cam real quick. And we've got spider web problems. I'm going to have to get the air duster out there and take care of that. So we'll move on to the charts and take a look what's happening around the Texas area. A little bit of thunderstorm activity down along the coast and up to the hill country. We should expect that sea breeze pushing inland. And by the sea breeze, let's see, we're talking about... I have to go to the polar orbiter for this one. Yeah, there we go. There's the polar orbiter data for about 12. And you can see the sea breeze coming inland, kind of a little line of clouds, already producing some showers right around the Port Aransas and Port Lavaca area. And then later, as the day goes on, we can see that moving inland already, producing some showers. And the other satellite, yeah, showing quite a bit of activity. So usually around this time of the year, we see Houston getting showers during the midday hours. And then those move northward, and they're left with fairly nice weather for rush hour. And what that means is usually that these push inland towards North Texas, and sometimes we find them in the southern parts of North Texas and East Texas. Pattern elsewhere across Texas, boundaries from the convection we had yesterday. I don't know how many of you have followed the MCS that moved through the Lubbock area last night, but let me see if I can zoom this out. Okay, Texas is located right here. And we had a big MCS develop, and it pushed southward overnight. And we found it around midday all the way down in the Pecos River Valley, around San Antonio. And there's some remnants of it just southwest of Abilene. And this is pretty important because this lays down boundaries. And we can see convection developing along those boundaries, especially where the 850 millibar flow impacts that surface flow, and 925 and 850. Those are definitely important. And up to the north over Oklahoma and Louisiana, looks like dry air working its way southward. All we see is low cloud, or high cloud, over Arkansas and Looks like we pick up a little bit of low cloud here in Kansas, and you can see more boundaries. This midday imagery is very important, so if you can, try to go back to that, because that could shape things for later during the day. Out in the mountains, looks like we have some orographic showers across Colorado and Arizona, and also more showers going on in the Oregon area. Looks like that front is finally pushed inland. And I was looking at it earlier up in British Columbia. The models were showing a very strong thermal gradient working southward through that area. And that's kind of interesting because fronts are usually very hard to find in the mountain regions due to the very rugged frictional effects through that area. That kind of disrupts the shape of the front down at the surface. Okay, we were going to take a little bit of a look at basics, and the big thing that we're looking for as forecasters is where vertical motion is going to happen. And usually that happens where the upper level flow is out of balance with respect to the pressure, height gradient, and Coriolis force. It can also, we can also find downward vertical motion where we have mass divergence at the surface, or if we're looking for upward vertical motion, we would look for mass convergence at the surface. And the opposite is true aloft, where we have upward vertical motion. We're looking for upper divergence, and that's a little bit harder to find because the upper level flow tends to be very laminar, like you can see here. There's some old rule of thumbs that say that where you have confluence, like you see right here in the upper levels, see that confluence right there, that was historically equated with downward vertical motion because we have flow coming together. But the problem with this is that you also have winds going from very weak to very strong. So let's consider that. We have very strong winds moving away from this area right here, and we have very weak winds coming in. And if you think of that as traffic, this is going to leave a huge gap that's going to widen. So this is a divergent effect, which offsets the convergence that you see in that laminar flow right there. So it's very hard to diagnose upward vertical motion because those motions tend to cancel out. So we're very dependent on model data to sort that out and find out where upward vertical motion is really going on. Now, of course, one way of finding vertical motion is to just look at the models and find out where it's showing vertical motion. Let me see if I can find an example of that. I'll just go straight to the model charts here. Look at, yeah, we'll look at the NAM. In fact, what I'll do here is I'll look at the NAM3. Okay, do we have vertical motion fields on the NAM3? We don't for some reason. Okay, we'll just go to the NAM and check that out. So we're looking at the vertical motion field at 700 millibars, which is about 10,000 feet. And you can see that the field is very noisy, especially out over the mountains. You can see out over New Mexico, there's a lot of noise in there, and we zoom in across the U.S. itself. Well, there's a few really red areas, but that could be convection. Thunderstorm clusters, maybe feeding it back into the models. Very noisy across the mountains right there, and very indeterminate. There's a little bit of upward motion shown in here, but normally it's very difficult to use these fields because a lot of the terms in the vertical motion equations tend to cancel out. And the magnitudes of those velocities are very weak, especially in stratiform conditions. So we can't necessarily head straight to these vertical velocity products. Now the models can sort this out to some bit, and you can just plot precipitation. So that's one way of doing it. You can just look at the precip fields. And sometimes these are accurate, but it's always good to go back and have a handle on the analysis so you know where these things are coming from. And quite often there's unexpected changes, so you have to be prepared. And if the system is shutting down or intensifying, you know why it's doing it and where that change would be increasing or decreasing. So in a sense, we're looking for vertical motion in the atmosphere, but we're also looking at the factors, especially that go into that vertical motion. And another form of vertical motion is convection. That's just heat being transported up through the atmosphere. Now the models have been historically very bad at handling that. The mesoscale models are getting better at that. They've got parameterization for convection, which means they can really drill down and handle those details. But they're still not very good, and I've seen errors with squall lines as great as 150 miles. Like I would see a forecast for 3 hours out here, and the system would be like way out here, for example. So the role of the forecaster is very important here. Let's look at things for today. We've got a slight risk over Kansas, even a severe watch box for that area. And they've issued a marginal risk for the deserts of Oregon and Washington, from about Spokane all the way down to Bend. And this is one way of getting a basic idea of vertical motion. We're looking at the 500 millibar field, and the coloring here corresponds to height anomaly, and you can think of this as pressure anomaly up in the mid-levels of the atmosphere, 500 millibars or 18,000 feet. So those heights are very high, especially up in the Arctic, so we're going to expect to find warm air in that area. And the heights are very low out over the Great Lakes and eastern Canada. And there was a relationship I talked about yesterday. If you go to the jet stream, which is where these lines are very packed together, you're normally going to find high pressure at the surface downstream from the ridge and upstream from the trough. So that's one way of finding vertical motion, because this implies convergence in the upper levels. That mass convergence would give us high pressure at the surface. So we're kind of piling air together through the column in this region right here. And the opposite is true out in the Atlantic. Out ahead of the trough, we would expect to find low pressure somewhere out there. And this would correspond to upward vertical motion, surface convergence, and upper level divergence. So for the most part, what we're seeing here, we're seeing what looks like a cold air mass across the eastern U.S. That's the whole reason for this trough here. This is a good indicator of a cold air mass out over the Great Lakes in eastern Canada. And this orange area is a good indicator of a warm air mass. And let's see just how warm it is. We'll take a look at current conditions. Let me get the latest. Let me see if I can take that all the way up to Canada. All the way up into the Northern Territories. I'll probably have to plot a new map for that. Okay, so we're looking at conditions in the polar areas. And we saw high heights aloft in the Canadian Arctic area. And yeah, you can see right along the coast here of the Arctic Ocean in the Northwest Territories, we've got 75. And there's a lot of scientists talking about Arctic methane release, and these warm temperatures up in the north would certainly not be helping that. 39 here and 45 along the northern coast here. But I saw it on the forecast models on June 2nd, June 3rd. They were bringing these Arctic islands up into the 70s. It's kind of a heat wave in store for that area, according to the Canadian model. And then further south, you can see a lot of 70s in through Yellowknife here. And this is underneath that upper level ridge. And looks like some warm air out in Alberta, Calgary, but looks like we have a cold front working its way eastward through this area here. We had a heat wave through this region yesterday. See if we can get a look at that. Remember, yesterday was 94 in Seattle and 94 in Portland. We've seen a big change. And we see westerly flow through Washington. Warmer temperatures out in eastern Washington, so looks like we've got a cold front working its way eastward across that area. So you can kind of see how that links up to the system up north. Looks like storms going through Calgary right now. And I meant to look at my Canadian radar. Let me see if I can grab that. So I was going to do an experiment here with Airstream. First, let me see if I can bring the Canadian radar up. And first we'll see if there's anything to see up in that area. Okay, I'm heading to radar site XSM. If there's anything to see, I'll bring that up. I'm going to go to WHK. Yep, yeah, we do got some storms up there. I'm going to do a test here. This may hurt the stream. You guys will have to let me know if you notice the signal start degrading. But let me bring up a program here called it's called X-Mirage, and this will let you guys see what we're looking at here. I've already got it running. Yeah, that's weird. I don't see that in the task list. Let me... Yeah, let me end that real quick. Okay, bring up X-Mirage, and we'll look at the Edmonton, Alberta high-res radar. Okay, so here I go. I'm going to start the stream. If this causes a problem, let me know. Here we go. Okay, so we're looking at Canadian radar. This is kind of rare. This is through radar scope here. And let me see if I can animate this. Got some very strong storms up there, just west of Edmonton. And these are associated with that cold front that's moving into that area. Let me see if I can bring up base velocity here. We don't have storm relative velocity, so that's one problem. And it looks like the range is not very good on these radars. But one thing that we can see is the strong easterly flow feeding into these storms. And we determine that by looking at the zero line, like this. And the shape of that tells us a lot about the environment out ahead of these storms. So we have close to the surface, looks like maybe a little bit of easterly flow becoming southeasterly aloft. And then maybe a little bit more, southeasterly aloft and then becoming a little bit more south-southeast. And then I think we're picking up the outflow of that system right out here. So I think that's the first time we've ever looked at Canadian radar. And let me see if I can go to another site here real quick. I don't know what else there is to see, but we'll just take a quick look here. I guess we're looking at the back of the storms up there in British Columbia. And then that system should be coming through the valleys of central British Columbia right there. Okay, so that's a quick look at radar scope, and I'm thinking of probably doing a radar scope tutorial one of these days. It's a pretty good program here. Okay, so I'm going to shut this off, and we will see how that experiment went. Okay, let's see here. Smooth stream. Okay, very good. Okay, heading on to the 250 millibar chart, this gives us kind of a good idea what the master solution is like in the atmosphere. So we got very strong jet stream energy over the east coast. Low pressure signifying that cold air mass, and underneath the ridge, this is where the cold air is. But we have troughing right off the British Columbia coast, so in between, this is where we expect to find the surface low. That's just northwest of Edmonton. So probably a warm front, something like that, and then a cold front like that. So do we actually find that? Let's take a look at the 500 millibar heights and vorticity. Or, I'm sorry, this is the 500 thickness and isobars. And looks like maybe, well, let's see, we're looking for the tightest packing of the thickness lines. Looks like it's something like this. Stops around Edmonton, and then you see the very strong packing in the British Columbian valleys right there. So it looks like that front is right through here like that. So through the eastern Washington deserts and northern California right there. And that's working its way eastward. I guess we'll see that in the Canadian Prairie provinces here tomorrow. And this warm front should be making it further north. This is also a boundary that we would be watching as forecasters. High pressure across the central Mississippi Valley, and that's moving southeast. That's going to merge into the Bermuda High, and we're going to start seeing the Gulf opening up here over the next few days. And one thing that we use a lot as forecasters is soundings. And just to give you a quick look, let's go down to the tropics. We'll go to Jamaica. And this looks very typical for the tropics. We've got a lapse rate that's not very steep. A steep lapse rate would be a line that leans more over to the left, like that. And the furthest you can go over is along the dry adiabats, like that. And sometimes that happens on the Great Plains when we have severe weather situations. Not this time. Instead of a very steep lapse rate, we have a very gentle lapse rate. It's what we call conditionally unstable, because it follows these lines. It's just a tiny bit over to the left. There's just a little bit of instability in the atmosphere there over the Jamaica area. And the other aspect is the very high tropopause. This is up at about 45,000 feet. And then you see on the winds, we have a lot of easterly flow. This is the tropical easterlies. And down at the surface, those tropical easterlies are called the trade winds. So let's check out soundings across Corpus Christi. This is southern Texas. So this also looks fairly tropical. Very gentle lapse rates. A little bit strong near the surface. Very moist conditions all the way up to about 20,000 feet. And then you see the easterlies in the low levels. And we start picking up the westerlies just above that. But very high tropopause also. Then we get up to Dallas. This also looks fairly tropical. This does have a little bit more of a westerly, strong westerlies, and you can see 50 knots up there at about 43,000 feet. So this is a little bit of a hybrid, but definitely a tropical appearance, and that's what we saw there on the open eclipse. Back there at the beginning when I was rolling the footage. Yeah, that's a very tropical atmosphere there. And just above that, you can kind of see the cirrus layer right there. So the soundings really give us an idea what type of air mass we have. If we go north, we see a very different air mass. We'll go to Aberdeen. This is in South Dakota. So much different appearance up there. You can see steeper lapse rates near the surface, a little bit more unstable. And we see a much lower tropopause. Very strong northwesterly winds. So all of this is showing us a very strong modification of the air mass in the low levels. Very low tropopause. That means a lot of cold air spreading into that area. But it's modifying quite a bit as it surges southward with these north winds. And let's see here over Alberta, where we're seeing those storms. There's Stony Plain right there. Looks like a very steep lapse rate. You can see how that leans way over. A little bit of cirrus aloft. And we don't quite see the loaded gun type sounding that us forecasters use, but it's very possible that they've seen modification of this temperature in the lower levels. So we go to the surface chart and look at the dew points. They're in Alberta, and we can see 60s coming up into the Alberta area. 59, that's about as high as it gets there. So 59 degrees, you know, that's 15 Celsius. That means that the sounding right now is actually kind of like this. And it may have considerable depth, so maybe it's, look, the moisture profile is looking like this. So as forecasters, what we do is we take the moisture line and we kind of lift it like this along these purple lines. We take the high temperature, in this case probably 85 degrees. It's going to be way over here. We lift that along the dry adiabats, which is these green lines, and that gives us the lifted condensation level right there. And then above that, we lift the parcel because now latent heat is being released. So it follows this line. This is basically the temperature inside the cumulus tower. And it rises until it uses up all of its momentum. Now this area right in here, this is called CAPE. Let me color this a different color. And there's a lot of CAPE in the atmosphere there. You see all that right there? So all of that represents buoyant energy. And when we talk about overshooting tops, basically all of this buoyant energy has to be dissipated. So we look for a corresponding amount of inhibition up here. So the geometric area looks to be about the same between that and the orange. So that gives us the height of the overshooting tops. So overshooting tops, about 150 millibars. That's going to be about 45,000 feet, maybe 47,000 feet. And then this equilibrium level right here, where you see this changeover, that's going to be the height of the anvil. So that's up at about 41,000 feet. And then the tropopause, that's just this black line that you see right here, the tropopause right there. So the equilibrium level, the top of the cells, a little bit higher than the tropopause. And that's where we see the tops of the cumulonimbus cloud. Bases are right here. So just drawing this all out, this is kind of like a look at what the cloud looks like right there. And then we can draw the overshooting top, kind of like this. So that's standing up probably about maybe a mile. And we see that very distinctly on the satellite pictures. Okay, we'll go back and check out those satellite pictures. There's the cells right there moving through Washington and Oregon along that cold front that we just diagnosed. You can see the marine layer working its way inland, getting hung up on the Cascades right there. And sometimes during very strong surges, that marine layer will move through the valleys and move inland into Portland, for example. And they end up with a very cold and cloudy day. And that's one of the things that forecasters look for in those areas. There's very weird terrain interactions that can pop up in the summer and in the winter. In the winter, they'll look for like gap winds coming from way inland. And those can bring very strong canyon winds, very damaging windstorms. So during cold surges, they'll be looking for stuff like that. And that's kind of what's involved with forecasting there. Let's try to take one more look at the Alberta storm. Geez, I don't think we can go up that far north. Yeah, we're stuck at, doesn't want to, NASA doesn't care about Alberta. Okay, great. Let me see if I can go back and pull out a large sector. Satellite images. Go to this full disk thing right here and zoom in high 1000. We'll try to take a look at what's going on way up there. Yep, there's our storms up there now in Alberta. Can we animate that? Okay, so this is almost live data and lots of light. I mean, it's dark where we're at. I was going to show you guys that. There's a spider web, though, kind of throwing off the infrared light. But up north, it's not dark. It is bright daylight, even though it's almost 11 p.m. there. Yeah, let me try one more thing. Let me try going way up north And we'll probably see the disk of the Earth and some of the Arctic regions. So here we see the midnight sun. This is up in Northwest Territories here. Yeah, all this is Northwest Territories, and Yellowknife is right around here. So bright daylight in that area. Looks like some sort of system moving through that area. And you see in effect what we call here, I'm trying to remember the term, I think it's called foreshortening, where you're kind of looking at a very deep angle, and it gets harder and harder to use the satellite imagery. And we could take a quick look at the North Pole. Let's check that out. God, we never do this. Okay, wait a second. I think that's as far north as it goes. Okay, that's the Canadian High Arctic right now, and you can see lots of daylight up in that area. So this is the midnight sun. We've had the summer solstice just last week, so plenty of daylight up in that area right now. And this is visible imagery. So even though it's midnight up in this area, we can definitely see what's going on way up there. Then I'm just going to take a look at the Atlantic, and we'll see the, I was hoping to see the disk of the Earth right there. Okay, so I guess we're just going to look at a little bit of Greenland. Okay, anyway, that's the satellite imagery, just kind of a little tour. Lots of things to see on there, for sure. Okay, let's take a look at the forecast now. Let's kind of move things ahead. There's the current dynamics right there. So you can see a lot of upward vertical motion working through Alberta and eastern British Columbia. Big ridge through Montana and Utah. So along that ridge and then downstream, we've got a lot of warm air. So very warm conditions through that region. Then down here in Texas, got a little bit of northerly flow, and looks like maybe some sort of trough aloft out across the Gulf Coast. And usually where we have a little bit of upper level troughing, that's where we find enhanced storm activity. And then this troughing that we see over the east coast right here, this corresponds to the cold air mass working through Pennsylvania and the Great Lakes area. And then just to look at things over the next couple days, looks like we have maybe a bit of a shortwave trough moving through the Illinois area. And by tomorrow, we often, this time of year, look for where those troughs are aligning with peak heating, so around 21Z. Trough all the way down to Georgia. Well, we may have not much low-level moisture up in New York, but it's a little bit more likely around Georgia. So if enough moisture is in place in this area, we could see thunderstorms out in this area right here. And we've also got another upper trough moving through Montana. So this could be another area where we could see thunderstorms develop because it's helping to destabilize the atmosphere. So pretty much two main regions we're looking for as far as upward vertical motion. And I guess that'll bring us to the forecast. And one quick look at the mesoscale forecast. We'll look at the high-resolution rapid refresh model for tonight. Showing just a couple storms across Kansas. I think that's pretty close to what I saw on the radar. And those will form up into a small MCS, move into the panhandles and Oklahoma overnight, propagate southward, and disappear at dawn. Okay, so a little bit of MCS activity along the Cap Rock of Texas right there. And then after that, the southerly gradient picks up, and we see cyclogenesis way up in this area here. And the trough moving through that area probably helping with that. NHC archive, let's see, that looks pretty quiet. And then out in the eastern North Pacific, probably the remains of Dora still out there. And another disturbance area about to form off the Central American coast there. Let's see, Dora is max sustained wind 90 knots, or yeah, 90 miles an hour. And just pushing to the west-northwest. Okay, let's see. This is probably a good time to look at chat. Let me get this ready. See what's going on here. Sue M., Carl Berghoff are here, and Ryan Toomey's deathly hot in South Florida. People getting struck down from heat stroke outdoors. Yeah, what are the temperatures in that area? Let me see here. Going to see if I had a sector that yeah, I've got a sector for Florida, so we'll just plot the data real quick. Of course, right now it's 9 p.m., so it's cooled down a little bit, but 83, 84 degrees at this hour there, and you can see the very high dew point, 74. A little bit of rain up in the central part of the state, though. Andrew is here, and Lloyd McCarter. Cloudy, bright, cooler morning here in Little Rock. I saw 70 degrees down here, which is kind of unusual. Justin Polium is here. Exciting topic for tonight. Burl H. Hot in Florida, rainy southeast Texas. 53 degrees in northern Wisconsin. Scattered weak storms with pea-sized hail. Carl says we're 25 degrees below normal today, but back up to 80 around midweek with more storms. Got Andrew Hoffman right down the road at Waxahachie there. Thomas Fortner is here. Carl Berghoff on a stormy evening in Texas. Texas flood would be a good intro, too. Stevie Ray Vaughan. That's probably a good way to get my channel in trouble if I start playing stuff like Stevie Ray Vaughan, even though I want to. Chances are they would just monetize the video, but there's also a remote possibility I would get a copyright strike on that. So I've had problems with that way back in 2011. So I'm a little bit... I would just hate to flush all this weather stuff down the toilet. Lots of thunderstorms in the sea breeze today here in Houston, where Thomas Fortner is. Such a rainy day. Chris, are you cooking stuff on the dashboard of your vehicle like some people in Phoenix? Ryan says it's darn hot. Justin is in Brazoria County. I'm going to have to copy this and keep up on my list of where everybody is. And I should start keeping a map. Yeah, I'm going to do that. I'm going to make a map of where everybody is. Dave Donate is from Canada. Thomas is in the Cyprus area. Tropics heating it up with a tropical wave popping up in the East Atlantic, south of the Yucatan. Let me see if I can see that again. Go back to that map here. I guess I can just look at the polar orbiter data. We'll just go down and scroll down. Off the Yucatan, well, let's see. Looks pretty quiet off Belize, but yeah, there's something going on along the coast of Honduras here. NHC says no major cyclonic action expected the next 120 hours. Brett Dean made it in at 68 degrees, severe in Jersey, southern New Jersey. Hodley from San Antonio from Jumpin' Flash. Ryan says the Pacific system off the west coast of Mexico moving west-northwest at 8 to 10 miles an hour. A little discussion there on the chat about Arctic methane. The melting permafrost could spell game over in this climate change tug-of-war. And you know what's funny? I read a Department of Defense paper. It's online about, I forgot what it's called. It's like the strategic vision for the Arctic Ocean in the post-ice pack Arctic Ocean or something like that. I guess they're looking at the idea of bringing the Navy up north into the Arctic Ocean maybe 10 or 20 years from now after all this melt. It's kind of depressing, but yeah, there is that document on there, and I've seen it, and it does look like it is a military paper there. Canada don't have the SRV radar, just reflection and velocity. Got a weak thunderstorm in Calgary. Okay, smooth stream when we did that radar way up there. Yeah, that's good to hear. So we'll probably do a radar scope demo here soon. Kind of like what we did with the McItis and AWIPS. Okay, so we'll head into the forecast here. Let's see what's happening over the next few days. Okay, starting out right now, we know that there's high pressure across Iowa. So we're getting a little bit of that northeasterly flow in Texas. That's keeping things kind of dry. And if we take a look at the dew points, you can see that kind of reflects that pretty well. There's the current dew points. And there's kind of like a boundary here between the tropical air, which is kind of unaffected around Houston, Lake Charles, still 70s dew points, but just north of there, very dry conditions. We're talking 40s and 50s dew points in Arkansas and Memphis and northern Alabama and all the way down to southern Georgia. So that's keeping things pretty nice, and that means cooler evenings. Drier air is more conducive to radiating out heat and cooling things down. And then north of that, you can see the very strong flow of moisture and this little band of moisture here in Alberta. That's what's keeping those storms going in the Edmonton area. And there's that little spot right there of 60s dew points, locally enhanced. So one little sounding from this morning, you can see that doesn't quite capture the moisture field. So the model data actually becomes kind of important because the model data can kind of interpolate and use previous soundings that we might have had in this area. So it's better at keeping track of that moisture. So if we had a severe situation, I would be looking at those moisture fields there. Okay, for tomorrow's webcast, we'll move things up, and Tuesday, very strong cyclogenesis in the Central Plains as that Pacific system pulls out into Montana and Wyoming. So I think we've got a bit of a cold front, maybe like this. That warm front lifting through the plains like this. You can see that little bit of troughing here in Nebraska. The cool polar high moving into Ohio, so that's gradually moving eastward, and we're starting to see the tropical air moving inland into Texas, south of that high pressure area as that moves off. So that may bring the sea breeze more inland. So even the GFS, you can see this is about 10 p.m. This is a little maybe remnant of the sea breeze right there. Looks like around Huntsville, maybe down to about Austin. Okay, for Wednesday, when we do Wednesday's webcast, looks like a boundary through the Central Plains, maybe an MCS moving through the Minneapolis area into Wisconsin. And you can see the Gulf is wide open. And most of the moisture is being fed north-northeast like that. So low-level jet will probably be in place early on Thursday. Or, let's see, when was that? Early on Wednesday. Okay. So then on Thursday, boundary holding on in the Central Plains, and it looks like that generates some storm activity. A couple of MCSs in the Kansas City area there. Gulf continues to be wide open. Then for Friday, looks like that boundary sags south into Arkansas and Oklahoma. You can see a little bit of ridging in the panhandle right there. And the front slowly moves through the Great Lakes area. A couple of clusters of thunderstorms moving from Wisconsin out towards the northern Michigan area. Okay, then for Friday, you can see the system including up there in northern Quebec. The main baroclinic zone looks like maybe something like this. Stalled across the Red River area of Texas. So thunderstorms in Oklahoma and Arkansas. Gulf is wide open and feeding those storms. I would guess about the only thing that would help them at this point is strong upper level flow. And behind this cool continental system, we might have a bit of a jet just north of this area of storms here. So there's a chance that that jet could enhance these over the weekend there. For Sunday, it's like the remains of that cold front through Oklahoma again still. Remains of the front in the northeast U.S. moving offshore. And the Gulf is wide open still. Should see a lot of cumulus on the webcam. And going into Monday and Tuesday, not a whole lot of change. Looks like a nice dry high pressure area moving through the Great Lakes area. Another Central Plains system moving through the Great Lakes. And things stay pretty quiet in Texas, but again, we've been looking at this area of troughing off the Texas coast. You can see initially how we have this onshore flow kind of uninterrupted for a few days, and then you can kind of see it go away right there. And it looks like that's because of something going on in Mexico, way down to the south. And that's important because that could make it up northward, depending on the steering currents. So we'll watch that. Yeah, there you can see. Looks like maybe some sort of tropical disturbance or a hurricane. Could be a hurricane, could be a tropical storm, could be just like nothing. But anyway, definitely a tropical, cyclonic, barotropic warm core system. Now, the other part of the picture is the 500 millibar, I'm sorry, the 200 millibar conditions, because this kind of dictates where your heat waves and very clear weather is. There we go. So it looks like we got a fairly active polar front jet, kind of coupling with a subtropical jet. Just a very strong westerly flow across Texas. That might help ventilate some of the sea breeze activity on the coast. And not much sign of a heat wave over the next couple of weeks. So it looks like a relatively mild pattern. Look at that. Looks like an upper level low of some kind over East Texas around Wednesday the 5th. That's significant. And it looks like that originates from the north. So this tells me Maybe there's northwesterly flow storms working through Oklahoma and Kansas and gradually working southward. So let me go back. Okay, see. Got a little bit of a wave kind of shearing off right there. That's probably convective. Little mesoscale convective vortex maybe. Moving south through Monday and Tuesday, the 3rd and 4th. Okay, so this could be a factor over the July 4th weekend in Texas. So we'll keep an eye on that. So there it is, just sitting across Texas on the 5th and 6th. Very strange, just sits there for days and days. And we do know that down in the Gulf there is some sort of tropical system around this time. Okay. Looks like maybe it shows up there very briefly. So let me go back and just look at the precip real quick. I was going to see what it was doing as far as precip across Texas. Not a whole lot, but with an upper level low like that, I would probably be a little suspicious. Okay. So anyway, we'll see what happens there. And let's see, one other thing. No, I'll probably save it for tomorrow. One thing I was looking at was temperature anomalies. Because this is kind of a useful product, I was looking at temperature anomalies across the world. I was going to probably talk about Australian weather tonight, but we're already running an hour in, so I'm probably going to save this for another time. But it is winter down in Australia, and they've got a bit of a cold outbreak moving into the western parts of that country there. So we should probably take a look at that tomorrow. But for now, let's see here. You can see this is a good product for finding cold fronts through the mountains. So you see right here, there's kind of like a division between abnormally cold air in British Columbia and very warm air out ahead of it. This is good for finding where those cold fronts are when it's very hard to locate. And you can see gradually it moves eastward into the plains. And you notice a lot of variation here. This is 18Z. This is during the midday hours. And it gradually... Basically, you see a lot of flashing here between very dark blue and mild conditions. That's a good indicator of dry air, because that can definitely allow temperatures to warm up to very warm levels where you have seasonably normal temperatures. Then at nighttime, temperatures go way down and you go below normal. So very strong temperature streams, that's indicative, or swings, that's indicative of a dry air mass. That's kind of what we're seeing here over the northern plains. But definitely looks like below normal temperatures around the 1st or 2nd, gradually moving through the northern plains. And then here in Texas, it looks a little bit warm since we're kind of close to that upper level ridge. And you can almost kind of trace the gust front maybe a little bit from whatever convection pops up around the 4th and 5th of July. Yeah, see below normal temperatures. I think that probably indicates maybe some convection going on across Texas, because we should see just kind of gradually above normal temperatures, kind of the same as what we see out here. This should all be rather homogeneous. Okay, then after 4th of July, looks like a bit of a heat wave for the Great Lakes and New York. It looks like our next system moves through the Great Lakes, and probably a cold front coming south, like that right there. This is on the 11th. And probably on the 11th, I will be broadcasting from Dallas, and I'll probably Be talking to Glenn. You probably remember him from the May 31st, 2013 tornado discussion. There's a really good video. Go back in the archives and you can find that. We're talking about the big tornado that affected El Reno, and caught up with chasers Tim Samaras and Paul Samaras and Carl Young. And so hopefully, I think he'll be joining us on that day around the 11th, and I think for the 4th we're going to stay here and just cook out and grill. So that sounds like fun. I'll try to take a little video of that right there. Okay, let's see here. One last look at the chat. Got quite a crowd here, and I appreciate you all joining. And if you newcomers have any ideas for things you want to see, even if it's basic stuff that you want to cover, just let me know. You can post a comment when this video archives, or you can email directly at weathergraphics.com on the contact page. You can do that. Brett Dean says, Tim, is it true where I live between Philadelphia and Atlantic City, it's known as a very hard area to forecast due to the mountains to the west and ocean to the east? I haven't heard that specifically. I can probably look in some documents I have here. I think I may have some forecaster notes from places like maybe Dover Air Force Base. I can check those and see if they say anything. But I don't think it's much of an issue. The mesoscale models we have now, they definitely help. Because I know further down in the Carolinas, the blocking the damming during the winter of cold air masses, like around Asheville and Charlotte, those were always a big problem for forecasters. And they developed the ADA model in the 90s to really address that. That was a big motivator for them to get that model online. And now we've got well, first there was the RUC, and now we've got the rapid refresh, the high-resolution rapid refresh. We've got all these nice mesoscale models, and they actually handle the weather very well past mountain barriers. So I think you're probably in good hands using the HRRR and some of these other models. Shred Days going to the beach after the July 4th. Some sort of tropical disturbance that week because of that. Texas from all airports, very good at the moment with American United, Southwest Airlines. From Ryan there. I guess that's pretty good. We should start the webcast with an update on the airline activity delays and flight delays and stuff like that. Private jets and commercial operations hit the brakes real good, though, when Mother Nature strikes. Florida will get bad with microbursts and downdrafts from their thunderstorm activity. Justin says there's always another option for diversion, so they tend to send the planes anyways, but your state's in the middle of the ocean. Nick says Australian weather is boring. Where was that? Lost my place here. Yeah, Australian weather boring compared to the U.S. That's what happens when you don't have a good barrier range like the Rockies or even the Andes. South America does get some interesting weather, and I saw a little bit of that when I was looking around yesterday. They've got winter down there, and looks like a couple of good cold fronts, very strong cold fronts. Australia doesn't have that barrier, so things are kind of flat, and you've just got kind of old cold front boundaries pushing inland and just kind of stalling out and not doing much. But one thing I was looking at, though, temperatures in the interior of Australia right now, it's winter there right now. If you in the very interior, highs right now are running around 55 to 60 Fahrenheit. But if you drive to the north, southern part of the North Territories, those are in the 55s to 60s. Then you get to the north part of the North Territories where Darwin is. That's on the coast. Temperatures in the low 90s. So that's probably a big change when you're traveling north through that area this time of year. You go from jacket and coat weather to having to run the AC. That must be kind of interesting. And then in September, of course, September, October, we pick up the morning glory clouds along the Gulf of Carpentaria. Those are pretty cool, and I'm going to probably try to show you some examples of that. We've done that in the past, but we'll cover that a little bit. But look up Morning Glory Australia, and you'll see some very interesting pictures on Google. El Reno, very interesting to shred days. Key West, final destination for Justin. That sounds nice. Lexi studied El Reno. Justin says basics are great. El Reno looked like a rotating vortex of death. Yeah, I was not out chasing that, but I was in Norman in my office there, and I was able to go outside and look up and see cloud-to-air streamers. Just the whole anvil was like radiating these long streamers of lightning way up there, like horizontal claws, like reaching out, and that was pretty ominous. And you could hear continuous lightning up there in the anvil. And I was really glad we were not out ahead of that thing. That was bad news. Okay, let's see here. Tim, thanks, Tim. Much exquisite work. Appreciate that from Brett Dean. He says, night all. Danaus enjoyed the webcast, thanks. And Lexi says, that sounds like Texas weather. North Texas freezing, South Texas sauna. Yeah, I never thought about that, but North Territories of Australia probably a little bit like Texas. All right. So anyway, I think that's probably going to be it for tonight. I appreciate you all joining. Make sure I have the right weather, right music. Yeah, I guess I do. Okay. So anyway, take care, and we'll see you all tomorrow. And stay safe.